Hello everybody and welcome back to another episode of Tableau Tip Tuesday, the series where we break some of Tableau's functionality down to its base elements so we can ensure that we're using it as efficiently as possible. For that reason, from beginner to expert, this is a great series for you to find some hidden gems to take your visualizations to a new level. Today is going to be part 2 in our 3-part mini-series of dashboard performance or workbook performance, if you will. Again, we're not focusing on the data model or the pipeline or anything like that, the columnar schema of our data sets. We're not focusing on that for this series. This will just be merely workbook performance. And today we're going to be adding filters to that list. So filters are generally a simple functionality that we're all very familiar with, but because of that, sometimes people won't go back and make sure they understand all the intricacies that goes into the filter functionality just because they think that they're easy and they know how to use them. So that being said, let's go ahead and get to work and break down all the different filter types and how we can use them in the most performant way. So the first one we're going to be going over is extract and data source filters. So these filters are unique because they are done on the data modeling canvas right here. All the way up in my upper right hand corner, you can see if I switch to an extract connection, I can now edit this connection. Now these filters are going to work like normal filters. So if, for example, I add a dimensional filter right here, you can see that this dialog looks exactly like a dimensional filter, as would a measure as well. Now the difference is going to come here in that these actively reduce the information that sits behind Tableau. So if you filter something out at the extract level, it no longer exists in the data pipeline, thus it will reduce the workbook size, which will inherently improve all forms of performance, from uploads to downloads to aggregations to any different performance that you can think of. If Tableau has less data to churn through, it's going to work quicker. Now the difference between an extract and a data source filter over here, so if I go even further up to the top right, we can see that we have another area to add filters. The only difference between these two is that an extract is going to take a local copy of your data that will exist on your local machine. So that can be an inherent security concern. So for that reason, a lot of people will lock their workers out of making extracts because copies of data can be dangerous. So for that reason, we have a database filter as well. Now these filters, again, if I add a filter and we go to a dimension, it's going to look exactly like a dimensional filter, but this is still going to reduce the amount of data sitting behind Tableau without taking a localized copy. So an extract removes the information, but then copies your data locally, and a database filter is just going to filter out that pipeline, but they both will still actively reduce the workbook size when you go up to File, Save As. It will be less data sitting behind that particular workbook. So those are unique in that sense, and we want to make sure that we're using them appropriately. And that being said, any columns that you don't happen to use in this particular workbook, just go ahead and filter them away. Remember though, that if I right click a column header and select hide, this is not the same as a data source filter. That will hide the column, but that data still does exist behind this instance of Tableau. All right, let's go ahead and take a look at how a filter is actually going to work. So if we just make a simple visualization here, so we have something to look at, and then we throw a filter on our shelf. What we want to take a look at here is this button right here called exclude. Now, essentially the way that Tableau is going to run these filters is that as soon as it finds a match, it places that match into a second column. Basically, it's found the value that you were looking for. Now, if I try and exclude certain values, it will function the way that you would think. It's going to exclude anything with a strike through, except that a machine is going to process these slightly different than a match. It loads the entire table first, and then it takes a second pass at that same table to exclude values that are supposed to be excluded. So based on that second pass, it's going to take a little bit longer to evaluate that filter. Now with a small filter like this, that's not going to have too many security implications, but if we are loading a larger list, such as a list of customer names, and we try and exclude just a couple, well, again, just remember that you have a lot of elements that you're loading and then taking a second pass at to exclude. So that kind of brings us to the idea of cardinality, just the number of aliases that belong under a given column header. So the more elements there are, the slower that filter is going to run, whether you're including or excluding, just based on the fact that it is a longer list. So just keep that in mind there. All right, next what we're going to go over is that we want to use a set wherever possible. So say, for example, we wanted to see our top 10 performing product IDs right here. We know that we can do that no problem just by making a visualization. We filter to our product ID, we go over to our top tab, and we just say, give me my top 100 products. And there you go. We have that right here. Now, if we want to use this same list of products anywhere else, perhaps we want to see some proportional brushing on a bar chart or something like that. Well, we would have to evaluate a second filter. So for that reason, it's always going to be a little bit more performant to make a set instead. So if I go to my product ID and I go to create a set right here, well, I can go to my top 10 or my top 100 products by sale again. Throw a name on that right there and press OK. And now I have all 200 of these values already contained within this subset, so there's no reason to re-evaluate the filter. So now if we wanted to see that proportional brushing again, we could just go to a lower level of detail and then put that new set on sales, and now we can see the proportion of sales that came from my top 100 customers while still only having to calculate who is in my top 100 once in the creation of the set rather than multiple times on the creation of the filters. All right, next up on the list is going to be showing relevant values. So I have a little visualization made up right here. It's just going to be category and subcategory. Now these two column headers are related as a one-to-many cardinality in that every category has multiple subcategories, but every subcategory has precisely one category. We can even see that reflected if I reverse the direction of those two fields. You can see now I have that repeated value on the one side of the one-to-many cardinality. So again, it's always going to be more efficient to nest them the way they're supposed to be. Now, how does this evaluate with regards to performance? Well, we can see it in our secondary filter value right here. I have the option of turning off subcategories or entire categories. Well, the problem with this is that let's say, for example, I only have furniture selected in my category. Well, an accessory is not furniture, right? There's nothing happen when I interact with that filter. So it's a better user experience and also a more performant environment to take that secondary filter, go into that drop down and say show only relevant values right here. So now whatever is set in my first filter up here, I only get the relevant subcategories that exist within that category. So that's another great way for you to steal back a little bit of performance right there. Last one that we have for you guys is going to be context filters right here. So context filters is something that Tableau's been doing a lot of work on. When I used to train years ago, I used to warn people that context filters can be slightly costly on your performance. That has changed. Context filters are optimized, and they're a very performant way for you to get things done. So for example, if we want to see our top 10 products per category, we know that if I go to my top 10 right here in my product ID, we're not going to get my top 10 per category. We're just going to get my top 10 products and wherever they happen to exist. Again, this product ID filter has no idea what a category filter is. So if we would like, we can add our category here, and we can add that to our contextual filter there. If this is confusing, I do have a whole video on context filters I would recommend you guys check out. But for right now, we'll just go ahead and add it to context so that whatever is set in this contextual menu, now you can see I have my top 10 just within furniture. And if I change my context menu, I have my top 10 within office supplies. Now, since this context filter is filtering out furniture and technology in this particular instance, it's removing that other information from the page. So again, there is still the same amount of information sitting behind Tableau, or this instance of the workbook. This particular sheet calls less information from the pipeline and therefore is going to reduce the size, which increases performance. So there you guys have it, a breakdown of all the different things that we can play around with filters in order to steal back a little bit of performance to keep people in the flow of their work. All right, that's all we have for you guys this week. Join us next week for part 3 of our dashboard performance series.